Hi everyone. This video is going to continue our discussion of Module 4B, which is talking about the scientific study of judgment, decision making, and reasoning. And for this particular video, I'm going to continue our discussion of various heuristics and biases, and we're going to talk about the representativeness heuristic. All right, so time to move on to the next question, right? So this question says, we randomly pick one male from the population of the United States. That male, Robert, wears glasses, speaks quietly, and reads a lot. Is it more likely that Robert is a librarian or a farmer? And 3 points extra credit for anybody that gets the reference in that particular image of a librarian. Okay, so what is this question illustrating about heuristics or biases in decision making? So this particular question is referencing something called the representativeness heuristic. And it's essentially a cognitive bias where the outcome is predicted based on how similar a particular example of something is to a typical example of that category, right? So a lot of us, for example, decide to eat healthier, right? Or when we're deciding to eat healthier, we might choose foods based on how similar they appear to be to other healthy foods, right? So for example, fast food restaurants kind of capitalize on this. So they make sure that if you order a salad from McDonald's or wherever, right, that it has the appearance of having lots of really leafy, kind of green, lush vegetables, right? And maybe there's a lot of buzzwords like organic and free range and things like that. So again, you're trying to make the food that you're selling appear to be very similar to the physical features that a lot of people associate with healthy food, right? Similarly, we might predict that a person wearing glasses will do better on a test than a person not wearing glasses, right? Because we associate people wearing glasses, they seem more similar to our prototypical example of an intelligent person. So how is this at work in the problem that I just showed you, the farmer and librarian problem? Well, by and large, right, it seems that the description of Robert as someone wearing glasses, speaking quietly, and reading a lot matched people's typical image of what a librarian is, or they matched their assumptions about what a typical librarian is like, right? And so overwhelmingly, most people decided that Robert was a librarian because the description that was given matched their typical description of a librarian, right? Thus, they were influenced by the representativeness heuristic into basing their judgment on how closely the characteristics used to describe Robert match the characteristics of a typical librarian, right? However, in making that decision or making that judgment, they were ignoring or discounting another important source of information. And that particular source of information is the base rates of farmers or librarians currently in the population, right? So when I say base rate, a base rate is the relative proportion of different classes of individuals in the population, right? So in 1972, when this experiment was carried out, there were many, many more male farmers in the population than male librarians in the United States. So just looking at the relative proportion of each occupation, right? It is much, much more likely that Robert is a farmer, okay? Because remember, Robert was randomly chosen from the population. So taking into account that there are many, many more farmers in the US who are male than librarians who are male, it would stand to reason that if we were to just pluck someone at random, right, that they're more likely to be a farmer. And by the way, those base rates are still true today. Even in 2020, there are more male farmers than male librarians, right? But people tend to discount this information, and they're instead swayed to overweight the importance of those descriptions or other characteristics that they're given, right? So basically, people aren't thinking about it in terms of probability. Instead, they're thinking about it in terms of how well their own description of a librarian fits with the description provided in the problem. Okay, so one reaction to the farmer-librarian problem might be that perhaps participants were not aware of the base rates or the relative proportion of librarians and farmers in the population. And so because they didn't have this information, they weren't able to use it to make the correct decision, right? Well, fortunately, researchers devised an experiment to examine what happens when people are given the correct base rate information. So, for example, some participants were given this description. So it says, in a group of 100 people, there are 70 lawyers and 30 engineers. What is the chance that if we pick one person from the group at random, that the person will be an engineer? Right? Well, when they were given this description, people had no difficulty at all correctly answering that 30% of people drawn from the population would be an engineer. So when they're given the base rate information, right, they seem to be doing pretty well. However, another group of participants was given the same base rate information, but they were also given this description. So this description says Jack is a 45-year-old man. He is married and has 4 children. He is generally conservative and careful and ambitious. He shows no interest in political and social issues and spends most of his free time on his many hobbies, which include carpentry, sailing, and mathematical puzzles, right? So when the second description is added to the first description, people's estimates of the probability of Jack being an engineer go up substantially, right? So what that means is that even when people are given the correct base rate information, they tend to disregard that base rate information whenever any descriptive information is made available. Okay, so people are really, really bad at prioritizing or taking into account the base rate in their estimates and will almost always choose descriptors above that. Okay. All right, so the next problem on your worksheet was the Linda problem. So it says, Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which of the following alternatives is more probable? Okay, so the correct answer to this problem is actually statement 1. So statement 1 has a greater probability of being true than statement 2. However, when Tversky and Kahneman asked participants the same question in 1983, 85% of their participants chose statement 2, right? And it's easy to see why they did this when we consider the representativeness heuristic, right? So many of the characteristics in statement 2 are typical of what most people think of when they think of feminists, right? So because that description included many of the characteristics of a prototypical bank teller, people were prompted to choose that option. However, that is a faulty conclusion. And again, we can see that it's a faulty conclusion by considering the base rate, right? So if we think about the probability of something occurring in the population, it makes sense to think about something called the conjunction rule. And the conjunction rule simply states that the probability of two events occurring together cannot exceed the probability of any of those events occurring by themselves, right? So said another way, the probability of A and B can't be higher than the probability of A or B alone, right? So let's look at a separate example. So for example, the probability that Anne has a red Corvette can't be higher than the probability that Anne has a Corvette, right? Because if we look at the pool of cars available, right, there are far more Corvettes than red Corvettes, right? So again, the probability of getting a Corvette is much higher than the probability of getting a Corvette that's red, right? And similarly, there are many more bank tellers in the population than feminist bank tellers, right? So when we look at the base rate or the relative probability that Linda is a bank teller, it's much more likely, or that Linda is a bank teller or a feminist bank teller, it's much more likely that she is a bank teller, right? Because the relative probability of just being a bank teller is much higher than the probability of being a feminist bank teller.